Welcome back, students. Lesson 13, binomial model. We're in video B. Let's practice with the formula. You saw from Kim Shepard on the previous video, we introduced this parking lot example, so every time you come to campus, you always try to get a spot down below. Usually you fail, you keep trying. From long-term experience, you know there's about a 25% chance you get a spot down below, and you're coming to campus 5 days each week. So we have a binomial situation. There's 2 outcomes per trial. There's a fixed number of trials, five days a week. Trials are independent, and let's see what that formula looks like. In general, the probability of getting exactly X successes in N trials. So here it is, big P for probability. Probability X equals X. This looks a little funny. This is an uppercase X. This is a lowercase x. So what's the chance I get X successes? There's 3 parts to this. They all get multiplied together. I'll put parentheses around each of them. Here's the first part. The first part is that N choose X piece, right? How many ways can I get 2 spots out of 5 days? So the first piece is N choose X. Here in parentheses is the second piece. It's P raised up to the X power. P is the probability of success, and I'll denote this at the bottom. I'll label everything. Last but not least, we'll use Q. Q is the probability of failure, and there will be N minus X as the exponents. Okay, so this looks a little intimidating, but really with practice in 1 or 2, it's actually quite easy. So what's all these letters mean? N is the number of trials. So in the parking lot example, that would be 5. P is the probability of success. And I'll put the numbers here too. So for this example, we have 5 trials, right? 5 days each week. P is the probability of success. So we said there's a 25% chance of getting a spot down below. What's left? Q over there. Q is the probability of failure. And if there's a 25% chance that we do get a spot, that leaves us a 75% chance that we don't. All right? And do we have any other letters left? N, X, number of trials. Yeah, X, sure. X. X is going to be what? X is going to be the number of times we get a spot. The formula will be the same. Those top 3 numbers, N, P, and Q, will be the same. And then depending on what the question is asking for, like I could say, what's the chance that we don't get a spot? Then X would be 0. No spots all week. What's the chance we luck out and get, say, 4 or 5 spots? Then X would be 4 or 5. And we use the same formula. Okay? So this is the general formula up top. This is specifically for the parking lot example. If you flip down to the bottom of the page, it says for this example, the probability of getting a spot down below exactly 2 days next week is, I'll leave the formula there, I'll erase the stuff at the bottom, and we'll plug the numbers in. All right, so probability, big X equals, let's see, exactly 2 days, right? So probability X equals 2. We do the N choose X part first. So let's see, this is the 5 choose X. Oh, 5 choose 2. We know the numbers this time, right? P is the probability of success, 0.25. And that will get raised up to the 2 power. So this is the chance I get a spot down below, and I want to get it twice. So 0.25 raised up to the 2 power. The Q is the chance I don't get a spot, 0.75. How many days are left in the week? If there's 5 days in a week, I've used up 2 for my bottom parking lots. It leaves me 3 left over, right? I'll write the 5 minus 2 here as the exponent, but realize that's the 3 days you're not getting a spot. Okay? Those 2 exponents always have to add up to the number of trials. So if we have 5 days, the total things you're multiplying over there have to be 5, 2 plus 3. All right, so that's what the formula looks like. It looks like we'll wrap this up as well. So we kind of know from the previous, we did 5 choose 2. You can check the previous example. That's 10. That's the first piece. If I'm doing this in my TI calculator, typically I would find this number first, and then I would just say answer multiply, and I would multiply by this one and hit enter. Get that, and then I would say answer multiply by, and I would do the last piece. Okay, it's just one big chain of multiplication. So 0.25 raised to this 2 power. Looks like I didn't do this in my notes. I wrote it like this. And maybe a little bit of simplification. So this sort of boils down to what? 10 times 0.25 squared times 0.75 to the third. All right, so it's a 0.2637 as the answer. Check on your TI that you can get this. And basically what that means, there's a 26.37% chance that we get exactly 2 spots down below and 3 spots up top, right? It's 26.37% chance that we get 2 spots down, which would leave 3 spots up, right? Up by the new buildings, the new math and engineering buildings. Now remember what's not the correct answer. I just can't multiply the chance of success, square it for 2 days, times the chance of failure, raise to the third for the 3 days. I do have to take into consideration all the different combinations, which is where the 10 comes from. All right, so not too bad. We'll flip over to the next page, clean up this messy board. All right, with probability distributions, we always can think about means and standard deviations as well. So, question, top of the next page. How many days each week should we expect to get a spot? Anytime in the statistics course you see this word expect, that's just code for calculate the mean. How many days do we expect to get a spot down below? That's the mean. Intuitively, right? Isn't there's a 25% chance of getting a spot? Aren't there 5 days each week? Shouldn't I expect 25% of those 5 days to get a spot? And if you, that is the formula, right? I mean, 25% of 5 is 1.25, and the formula for the mean. We'll use that symbol mu like we did for normal models. Basically, this is your number of trials. This is n. This is your probability of success. It's just n times p. It's the easiest formula for a mean of the whole semester. It's number of trials times probability of success. The mean for the parking lot example, we know that it's 1.25 days. Mu equals 5 times 0.25. Don't round that to 1. I know you can't get a spot a quarter of a day, but the answer is 1.25. Okay, don't round that down to a whole number. And what we're saying is that each week we should expect to get a spot on 1.25 days. Okay, with the mean always goes standard deviation, so here it comes. The formula, at the intro stat level, not as intuitive. The formula for the mean is pretty darn intuitive. Makes perfect sense to me, hopefully you as well. Standard deviation, just trust us. Here's the formula, sigma. Same symbol we used for standard deviations for models. So sigma equals, you get a square root in there, it's n times p times q. If you move on in statistics, you might explore why this is the correct formula, but at this level, just trust us that that's the formula. For the parking lot example, we can calculate this pretty easy. Sigma equals big square root. How many trials did we have? We had 5 days, right? What's the probability of success? Same example, 0.25. What's the probability of failure or that we don't get a spot? 0.75. Whole thing square rooted, I have no idea what that is. I did my homework though, 0.968. This is about equal to 0.968 days. You know, if you want to try to interpret this, it's roughly a day, awfully close to 1. I'm not saying round it to 1, but I'm saying it's roughly a day. And if you think about it, each week you expect to get what? About a spot and a quarter of a spot. Standard deviation is 1, so would it be unusual to get no spots? I don't think that's unusual. That's roughly 1 standard deviation below the mean. Would it be unusual to get, say, 2 spots in a week? No, because the mean is 1 1/4 spots plus about 1. Would it be unusual to get a spot all 5 days? I think so. Common sense tells us yes. And using the standard deviation, we can see that might be about 3 standard deviations above the mean. So if you lucked out and got a spot 5 days in a row, I mean, that's a pretty lucky and unusual event. All right, I think one more page. Yep. So we know means and standard deviations. Those look easy. The formula might look a little scary still, so we should practice once or twice more. And I'll give you a little secret. When the number of trials is small, like 5, the formula works just fine. In a couple videos, there's actually a StatCrunch shortcut that will calculate these things automatically. But for now, formula students. For the parking lot example, what's the probability that we get a spot 4 of the 5 days? I like to make a little list here. My n is 5 days. This time x is 4. We'd like to get a spot on 4 of the 5 days. For this whole problem, p is always equal to 0.25, and q is always equal to 0.75. Here's the formula. Probability x equals 4. You've got the formula in letters and symbols 1 page back. I'm just going right to numbers because you can just flip your page or rewind the video. So to save some space.